Welcome to Nakamichi Spoken Here, number 4. This, our winter 75-76 edition. This is Harren Appelman, and this time around I'd like to discuss a little bit with you about cassettes. I'd like to discuss a comparison that's often made, cassette versus open reel, some of the problems with the cassettes themselves, and discuss a little bit about the history of the cassette medium, and finally I'd like to mention something about the Nakamichi Performance series, and this I'll explain later on. I'd like to preface these discussions, though, with a couple of remarks. And first of all, Nakamichi Research is generally considered today to be the leading cassette manufacturer in the world. This from the standpoint not only of the performance of our machines, but the vast experience we have in the cassette medium. Nakamichi today is considered the reference standard. You'll find our Nakamichi 1000 at all the major cassette manufacturers and the music cassette manufacturers. Our machines are used for evaluation and testing of cassettes. This unique position of leadership, perhaps makes it very appropriate for us to make comments relevant to the cassette. First thing I mentioned was the comparison of cassette versus open reel. This comparison is made for us a lot by other people. In our case, especially because we have because we do make the top cassette machine. When you're comparing cassettes open reel tape, let's take 15 inches per second half track studio grade open reel. When you compare that to cassette, you have 8 times the tape speed and about 4 times the track width. Not the tape width. And this means you have roughly 32 times the energy involved. Naturally, in the case of cassette, that means your signal to noise and your distortion isn't going to be as good as a 15 IPS open reel. And furthermore, you're going to have wow and flutter problems resulting from slower tape speed. These are precisely the things that make people skeptical about cassettes. But I think we've erased a lot of the skepticism with the introduction of our 1000 and later on our model 700. At first, people used to say, well, yeah, the Nakamichi machine is good. And people still say this. It's good, but it's too expensive. For that kind of money, you might as well spend it on an open reel machine. But, the sales of our admittedly expensive cassette decks, though, have risen to unexpectedly high levels. I think people who are buying very expensive open reel machines are also going out and buying our very expensive cassette machines. And there's reason for this. The very obvious reason is the ease of handling that cassettes afford. Not just ease of handling when compared to open reel, but also when compared to disc. Also, the operating cost of a cassette machine is about 1/10 that of an open reel machine running at 15 IPS half track. We've never attempted to, and our intention is not to make open reel obsolete. We recognize there's a place for open reel as much as there is place for cassette. For professional use, where editing is a requirement, you have to use open reel, and there's in that sense, we've never pretended that we could make a machine to match professional open reel machines in every feature. We would like people to be aware, however, of the limitations with open reel. The main problem, which we've experienced, is a tape skew problem. This is the skewing of the tape. This causes poor phase relationships above 5 kilohertz in the case of open reel. This really isn't dependent so much on the tape speed. It's mainly due to the great distance between the tracks in the case of open reel. This was not discovered to be a problem until Matrix 4-channel appeared on the market. That is to say, when you have your 4-channel matrix material, it's recorded onto a 2-channel open reel machine. Because of the poor phase conditions above 5K, you got very poor 4-channel imaging above your upper mid-range. In the case of the cassette, however, thanks to the smaller distance between the tracks, you get very good phase relationships, right up to about 10 kilohertz. Of course, your outright separation in dB is much better in the case of the open reel, but on the cassette, the separation is good enough so that with the minimized skewing, your 4-channel imaging is much better. Now, there's a case in evidence of what I'm saying here. In 1972, at the London Hi-Fi show, the Sonex, a group of people from the Oxford University did experiments in ambiophonics. It was a 3-channel matrix system using your XYZ spatial axes. They were originally doing these experiments with open reel machines, but they found that this skewing problem that I mentioned gave poor imaging because of the poor phase relationship above 5K. So what they ended up doing was using a Model 700, our Model 700. This is all documented in a article which appeared in Audio Magazine about that time. Next, I'd like to go on to problems with the cassettes themselves. In Nakamichi Spoken Here, number 1, our spring edition, I mentioned that, there was a question. The question was, why is there a user-adjustable azimuth control provided on the Nakamichi 3-head machines? And the answer was, the problem is that cassettes aren't as precise as we'd like them to be. They're inconsistent, and you have to have some way of adjusting for this. But I'd like to answer that now a little more specifically. First of all, there are friction problems, and friction problems come from 2 sources. In the case of cassettes, there are Teflon sheets that line the upper and bottom sides of the cassette to cut down the friction between the tape and the cassette housing. And the Teflon sheets help, but it hasn't completely eliminated friction, with the result that you still get a certain amount of friction. Also, you get friction from the pressure pad, which is an integral part of all cassettes, as you know. This friction causes wow and flutter problems, and causes tape speed problems, and also causes mechanical noise. And second, there's the tape and guide roller problems. This is a combination of guide roller design and also poor tape slitting. The width of the tape isn't as constant as you might imagine. There's a lot of variation among manufacturers, and also even in one cassette you can have a variation of the tape width due to the poor tape slitting processes. Now, the guide roller leaves too much play in order to compensate for some of your wider tape widths, and what happens is that the tape starts waving up and down. What this causes is, in audible terms, is a fluctuating recorded level. Now, the guide rollers sometimes do not roll smoothly. They vibrate, and this affects the tape-to-head contact, and you get a fluttering kind of effect. Also, the guide rollers are very often skewed. They're slanted off to one side. Not only the guide rollers, but the tape guide posts, the plastic posts, which, because of asymmetry in the upper and lower halves of the cassette, they're supposed to be symmetrical, but due to unintentional asymmetry, these posts can come out slanted. And this causes azimuth misalignment problems. There's also a problem with the deformation of the plastic housings themselves, that with time they can actually, if you expose them to heat a little bit too much, they can deform enough to cause a lot of these problems that I mentioned above, to make some of these problems worse. There's also a problem with vibration of the tape and horizontal resonance modes. Anytime you have any 2 points of contact with the tape, that is, for example, between a roller and a guide, or between a guide and a head, you have resonance modes, and this causes vibration, which can cause tape squeaking. Squeaks against the head. This is also a problem with open reel, but because the tapes themselves are much thicker in the case of open reel, the effect isn't as noticeable. Now, I think you can see from all this why sides A and B of any given cassette can differ in tape traveling characteristics. When you had two head machines, where your record playback head was one head, and that was located in the geometric center of the cassette, this was not a problem. Sides A and B, you had pretty much the same thing, mainly due to the because of the fact that the head was located at the geometric center of the cassette. However, in three-head designs, this became a major problem because the record head is off to one side, and the asymmetry of the cassettes necessitated the azimuth adjustment that you find on our machines. Back when Philips first introduced the cassette, they introduced at the same time the little carry recorder, the small cassette recorder, monaural. Back when the cassette was first introduced, the upper limits of frequency response was about 5,000 to 6,000 cycles. This was considered plenty because the cassette was mainly for dictation, for voice, maybe background music. Then in the mid-'60s, when a cassette the stereo format became standardized for cassettes, 8,000 cycles, it was decided that 8,000, if you had response out to 8,000 cycles, well, that would be plenty. And if you had separation between channels of about 15 dB or so, that would be plenty. In other words, very clearly, the cassette wasn't intended as a high-fidelity tape medium, and this much was made very clear to Mr. Nakamichi. Philips was not after high fidelity. So Mr. Nakamichi decided he'd go after high fidelity on his own. The first step was to extend response out to 10 kilohertz. The second step out to 12 kilohertz. And the third step, the third barrier, if you will, was out to 15 kilohertz. And the fourth step, which we achieved in 1972 with the Model 1000, was extending response out to 20 kilohertz. Improvements. These improvements, of course, resulted from improvements in the machines and the heads, transport, so forth, electronics. But of course, a lot of credit has to go to the tape manufacturers who came up with new and improved tape formulations. So what I'd like to do now is explain to you, go over the history of cassettes and how some of these tape formulations, which we have today, came about. A lot of people still think today that the cassette was originally Philips' innovation, but this is not quite true. The very original version of the cassette belonged to RCA. They had a cartridge, rather large cartridge. They used regular quarter-inch tape, and the basic idea originated with them. The problem was that the tape friction was too high. Since you were using standard quarter-inch tape, the mass was rather high. You had too much friction, and also the playback equipment, the associated equipment, was just a little bit too expensive to make it practical. What Philips did was take this RCA cartridge and shrink it down, and of course they've been very successful. But I should mention that there were other endeavors along this line before the Philips cassette. For example, 3M tried a little 3x3 inch by 3 inch cassette system, but this failed because it was basically over sophisticated, and the equipment was once again too expensive. Also, a number of German manufacturers got together and put out a cassette. The format was about twice the size of the Philips cassette, but this failed mainly due to poor timing, and also the fact that Philips moved very fast with their cassette. They made some good marketing moves and had already created a mass market and a standard before this German cassette was before this German cassette became a reality. Well, once tape manufacturers, and I would say here I'm talking mainly about Japanese tape manufacturers such as Sony, TDK, and Maxell. Once these tape manufacturers got the license from Philips to manufacture cassette tapes, the quality started getting quite good, and the quality started to improve little by little. In the latter 60s, when TDK had just put out their SD, the super dynamic tape, Nakamichi Research was in the second step. That is, we were challenging the 12 kilohertz frontier. It was difficult to extend the response out to 12 kilohertz, but that mainly because of the noise problem. Yeah, we could get response out to 12,000 cycles, but the problem was getting decent signal-noise ratio. Fortunately, right about that time, we made our connections with Dolby Laboratories. As most of you know, we manufactured the KLH Model 41 open reel deck. This was the first consumer unit to incorporate the B-type Dolby noise reduction. And it was very natural that this would later be incorporated in cassette decks. So thanks to TDK-SD and Dolby, we were able to reach our 12 kilohertz goal. A little later, chromium dioxide, mainly due to failures on the computer market, became available for cassette. Henry Claus, who by then had started Advent, he was pushing chromium dioxide with Dolby for cassette use. Chromium dioxide brought us into the third step, that is extending the response out to 15 kilohertz. And it was the combination of chromium dioxide tape and Dolby that brought the whole cassette medium into the realm of hi-fi. Close collaboration between Henry Claus, Mr. Nakamichi, and Ray Dolby produced the world's first high-fidelity cassette deck, the Advent 200. After the start of this collaboration, Mr. Nakamichi pushed chromium dioxide with Dolby, this cassette format, to other manufacturers, Philips, North American Philips, Sony, Superscope, TIAC, and many others. And the reason for this is that Mr. Nakamichi recognized back then that if this was to become a standard, it would be necessary to have a competition among the top makers. Well, finally, about 2 years after Mr. Nakamichi started encouraging the use of Chrome and Dolby, it wasn't until about 2 years after that point that these manufacturers finally came out onto the market with cassette machines with the chromium dioxide equalization and with Dolby noise reduction. But by this time, Nakamichi Research was well into the three-head technology. And by the summer of 1972, the prototype of the present Nakamichi Model 1000 had been completed. And that same year, in the fall at the New York Hi-Fi Show, the Nakamichi 1000 was exhibited on a trial basis. And in 1973, thanks to a very positive reaction, Nakamichi Research, Nakamichi Model 1000 became a reality on the U.S. market. Right about that time, though, we noticed we were beginning to have problems with chromium dioxide tape. And then these were problems mainly in the quality control area. We found that the tape characteristics, the bias characteristics, the high frequency response above 10 kilohertz varied widely from lot to lot. So Mr. Nakamichi went to DuPont to discuss some of these problems. As you know, DuPont supplies just about everybody with just about all the tape manufacturers with chromium dioxide, since they have an exclusive rights on that at the present time. And what Mr. Nakamichi found out at DuPont was that the chromium dioxide coating process is very complex, and it's very difficult to maintain a level of quality control. What we do with the chromium dioxide that we buy from DuPont is we throw away a lot of it, and that's really the only claim we have to putting out a higher quality product. Since everybody buys the same chromium dioxide tape from DuPont, how is it that one manufacturer can say we make a higher quality product? Well, it's because we throw away more of the tape that we buy from DuPont than other manufacturers do. Different manufacturers have different standards, and they throw away different amounts. That's about the only control they have over chromium dioxide, since they're not manufacturing the raw material itself. In this sense, it's important to understand that not all chromium dioxide tape is the same, even though the source is the same. Also, about the same time, the low noise, high output, high frequency boosted tapes, such as the Maxell UD, came into the picture. it was a very good thing at that time because many machines with poor response, poor high frequency response, mainly due to poor heads and electronics, so forth, got a lot of help from these high frequency boosted tapes. If you don't readjust the bias for the Maxell UD type tape, of course you get a very bright sound, and this was very helpful to a lot of the early machines. And other manufacturers followed suit. In 1973, in Europe, BASF introduced the LH Super tape. In Japan, Fujifilm introduced their FX tape, which only very recently became available in the United States. And in the U.S., in 1974, 3M Scotch introduced their new high energy, and Ampex introduced their Plus 20 tape, and there are several others. All of these are the low noise, high output types, like the UD, Maxell UD. What we did at this point is we started adjusting our machines for the high output type tape, because these tapes were becoming widely available. And as you know, in the normal position today on all our machines, you can use this type of tape. Although it's specifically adjusted for the EX tape, which we also put out about that time. The thing that surprises us is how well our EX and our Chrome tape has been selling. We don't manufacture these tapes, as you know. We originally put them out for reference purposes, for our own protection, but they've really started to pick up in sales. And I guess it just goes to show you how well, goes to show you that a lot of people are willing to pay that extra amount to get the little bit extra of quality control. What I'd like to do here is speak to you about some new tape formulations out on the market. Most of these were introduced at the CES in June this past year. We have experimented with all of these tapes at one time or another, and we of course have files and a complete set of information on all these tapes. We perhaps gathered data about tapes more than any other manufacturer. We perhaps do more experimenting on tapes than a lot of tape manufacturers themselves. And of course, we don't just experiment with samples that we get from manufacturers. We get samples galore, as you can imagine, mostly unsolicited. But what we do is go out to the stores and buy the same tape that a normal person would, because very often samples that we receive from a manufacturer are not representative of what's out on the market. Now, it would really be improper for me to comment at this point on all these tapes and naming them by brand. So what I suggest you do is, if you have any questions about any particular kind of tape, whether they're fit for use on our machines or you just want to know our comments, our opinions, of course you can write to us or call us, and we'd be glad to discuss tapes with you anytime. But let me just speak generally for a moment. We are fairly negative on some of the new double-coated, the ferric oxide and chromium dioxide double-coated tapes, because of problems I mentioned in previous tapes, problems with dropout and so forth. And now, of course, there are even more low-noise, high-output, and high-frequency boosted tapes out on the market, and some of these are very good, but while all of them have their strong points, they also have problems. They have problems with housings. Some of them have problem with the oxide falling off, things like that. And once again, all I can do here is to recommend that you use our tape as reference, and you can make your own comparisons and draw your own conclusions. Of course, we introduced our new EX2 tape, which is really ideal for that kind of reference use. It's a ferrocobalt formulation. And I mentioned this, I believe, in Nakamichi Spoken Here number 1, but compared to our own EX tape, it has lower noise, lower distortion, increased sensitivity, and maximum output level. and it can be used at the same bias settings as EX. But I can tell you so much technical information about this tape. What we'd like people to do is take the EX2 and make recordings with it. And I think that you'll find that the sound is cleaner, you get greater latitude, and you get the headroom is really excellent on this tape. What we're suggesting is that for normal applications, that the user stick with our EX tape. Our EX2 is a bit more expensive and should be reserved for your most critical applications. Although I think perhaps a lot of people with super critical ears may prefer to use EX2 all the time. Above all, we hope that people will compare our EX2 to chromium dioxide tape. We think that EX2 will come out a little bit ahead in comparisons like that. We're particularly happy about EX2 because it's a way for us to sort of get around the problem of the quality control problems we have been having with chromium dioxide, the fact that we've been having to throw away so much of the chromium dioxide. Now, in the little bit of time left, I'd like to speak with you briefly about the Nakamichi Performance Series. These are live performances sponsored by Nakamichi Research, and at these performances there will be live recordings made with our equipment, our Studio Z professional cassette recorder, and our 3 microphone system whenever possible. And these tapes made at these performances will be dubbed 1-to-1 at 1 7/8 onto our EX2 cassettes, and the result should be sound that can't be found on discs or any other pre-recorded tape, which is made with high-speed duplication. This is a part of a dream that Mr. Nakamichi personally has had for a while. It's a dream that a lot of us here at Nakamichi share, and we're not really looking for large profits with this project, at least not for the first few years that we attempt it. What we'd like to do is get more people into live recording, perhaps initiate exchange programs, exchange of these 1-to-1 dubbed cassettes. I realize this kind of thing has been tried in the past with OpenReel and not very successfully at that, but we think that it's different with cassette, well, we depend on you dealers a lot to encourage live recording. Now, our demonstration tape this time is the same. It's from the same source as for Nakamichi Spoken Here number 3, and it comes to you courtesy of Ken Kreisel of Miller Kreisel Sound Incorporated. Ken is the recording engineer for these recordings. I hope you enjoy these selections. And we'll be with you again next time with Nakamichi Spoken Here number 5.